Okay, let's start this video. Before we talk about new material, I want to clear one point which I didn't make it very correct or clear. So in the last video, we mentioned some identity. Secant inverse of x is equal to cosine inverse of 1 of x, and cosecant inverse of x is equal to sine inverse of 1 of x. These two identities are correct for all reasonable x. X is not equal to 0. X is greater than 1 or less than -1. Okay. I also mentioned that the cotangent inverse of x is equal to tangent inverse of 1 of x. And this identity is correct in this textbook only for positive x. Only for positive x. The reason is that in our textbook, y equal to tangent inverse of x has a range -power 2 to +power 2, and y equal to cotangent inverse of x has a range (0 to +2). Okay, so that's they have different range. They have totally different range. So only for positive x, tangent inverse of x and cotangent inverse of x are both in 0 power 2 in the first quadrant. When you have a negative x, then tangent inverse for negative x, tangent inverse x is in the fourth quadrant. And the cotangent inverse of x is in the second quadrant. They are even in the different quadrants. So for the negative x, they are never equal to each other. For our definition of a cotangent and tangent inverse, if you modify the range of a cotangent inverse, we can make them equal to each other. But it's not that important to have this identity. So we just still fix our range like this. Cotangent inverse has a range from 0 to pi. Okay, so we do not want to just get one identity by selecting different range. Okay, so we don't do that. This definition is still the definition on page 618. Okay, so that's a minor stuff. We can make this an identity for all x, but it's not necessary. Okay, so if you want to use the identity, you can choose x positive. Otherwise, just ignore the identity. And also, I mentioned those identity because I want to tell you that sine inverse, cosine inverse, they are sufficient for us to study the inverse trick, because secant and cosecant, they are represented by the sine inverse and the cosine inverse. Okay, so that's the reason for this discussion. Otherwise, you don't have to memorize those formulas. Okay, now let's talk about the new section, section 8.3. Trigonometric equations. Trigonometric equations has equations involving trigonometric functions. Okay, So first, we start from the simple verifications example. So determine whether theta equal to pi over 2, pi over 4 is a solution of the equation of the equation of 2 sine theta minus 1 equal to 0. Okay, determine whether this angle is the solution of the equation 2 sine theta minus 1 equal to 0. Is theta equal to pi over 6 a solution? Oh, okay, so this is the second question. Okay, to verify a number is a solution or not, you just plug in from left side and see if you can get the right side. Okay, so for theta equal to pi over 4, we know that the sine theta is square root of 2 over 2. So 2 sine theta minus 1. For this moment, you don't know it is a identity or not. So you always start from one side, you get the other side. So it's 2 times square root of 2 over 2 minus 1. So cancel 2, you get the square root of 2 minus 1. And we know square root of 2 is not equal to 1. So this is not equal to 0. So we get our statement. So theta equal to pi over 4 is not a solution of the equation. Okay, so that's the first question. And second, for theta equal to pi over 6, theta equal to pi over 6, sine pi over 6 is 1/2. And then 2 sine theta minus 1 is equal to 2 times 1/2 minus 1 equal to, well, it is equal to 0. 2 times 1/2 is 1, 1 minus 1 is 0. So theta equal to pi over 6 is a solution of the equation. Is a solution of the equation. Okay, so this is again the test of the memory. So you have to really memorize that evaluation table about the sine and the cosine. If you don't know the value for the angle, special angles, pi over 6, pi over 3, pi over 4, pi over 2, if you don't know those values, then there's no way to get it correct. Okay, so before we do that, let me recall that how do we memorize it. Okay, so let's start from the 0, pi over 6, pi over 4, pi over 3, pi over 2. Okay, then let's continue. You see here, we're going to 6, 4, 3, 2, and then we're going to 3, 4, 6, the denominator. So we've got a 2 pi over 3, 3 pi over 4, 5 pi over 6, and the pi. Okay? And what's next? Continue. You get 6, 6, 4, 3, 2. So you get 7 pi over 6, and 5 pi over 4, and 4 pi over 3, and then 3 pi over 2. And again, you get 3, 4, 6. Okay, so you get 4 is 5 pi over 3, and 7 pi over 7 pi over 4, and what's next? 1, 5, 7, 11 pi over 6. 11 pi over 6 and 2 pi. Yes. 11 pi over 6. So it's just a pi plus 5 pi over 6 is 11 pi. And the pi plus 3 pi over 4 is 7 pi. And 7 pi over 4. Pi plus 2 pi over 3 is 5 pi over 3. Okay? So that's a way to get it. And this part is always the first part plus pi. Okay? So this the second half is the first half plus pi. Okay, you see pi over 6, 7 pi over 6, pi over 4, 5 pi over 4, pi over 3, 4 pi over 3, pi over 2, 3 pi over 2. Always addition. Okay, so that's a way that's a memory for the angles. And for the values, sine. So this is 0, 1/2, root 2 over 2, root 3 over 2, 1. And you go down and root 3 over 2, root 2 over 2, 1/2, and 0. Okay, and then you're going to repeat this, but with negative signs. So it's negative 1/2, negative root 2 over 2, negative root 3 over 2, negative 1. And negative root 3 over 2, negative root 2 over 2, negative 1/2, and 0. You see, the second half is identical to the first half, but with negative sign. So that's why we always just memorize a quarter. You have a quarter, you flip the quarter, get the second quarter. And then you get the first half, you copy the first half, put a negative sign, you get the second half. Okay, so that's always a case. And then let's memorize cosine. Cosine, how do we memorize a cosine? It's very simple. We just start from 1. Okay, we get 1, root 3 over 2, root 2 over 2, 1/2, and 0. And then you start from here. Okay, so negative 1/2, negative root 2 over 2, negative root 3 over 2, and the negative 1. And this one, negative root 3 over 2, negative root 2 over 2, negative 1/2, and 0. And then you start from here. 1/2, root 2 over 2, root 3 over 2, and 1. Okay, you see, the cosine is just shift of a sign. The shift of sign. You memorize sine, you flip the other half, and you shift it. You shift it to get the cosine. So sine, cosine is actually very simple. You just memorize 5 angles. You just memorize this. All the part can be made based on this half. This a quarter. Okay, so that's a way to memorize the trig angles. And then let's use this memory to answer the questions. Example. Solve the equation cosine theta is equal to 1/2. Cosine theta is equal to 1/2. Check here. So we know what? We know for theta is pi over 3. Cosine pi over 3 is 1/2. If you don't memorize it, of course, if you memorize it, you will see theta is this 5 pi over 3. Cosine 5 pi over 3 is 1/2. So these two are the solutions in one period, in one cycle. And it's a periodic function. So the solution set is theta equal to pi over 3 plus 2k pi, or theta equal to 5 pi over 3 plus 2k pi for all integer k. Okay, this is a solution set. You find two solutions in one cycle and you put 2k pi. So memorize it, you get the answer. Okay, the second way, if you just know that cosine pi over 3 is a solution, remember that cosine is an even function, so cosine negative pi over 3 is also equal to 1/2. Then what you can do, you can say the solution set is theta equal to 2k pi plus pi over 3, or theta is equal to 2k pi minus pi over 3 for all integer k. Okay? What's the difference between them? Negative, okay, this is the second way. First way, you just recall the table and find the answer. Second way, you just use the even property for the cosine. You find one angle, put a negative sign, you get the other angle. The difference between them is that negative pi over 3, if you add 2 pi, it is 5 pi over 3. So actually they are one-to-one, there is a one-to-one correspondence between them. You just choose the previous angle as a reference angle, not reference, as a sample angle, not 5 pi over 3. The same thing. These two solution sets are the same thing. Okay, so you can use either of them. If you have a good memory, use this one. If you have if you want to use a even property, you use this method. Either works. They are both correct answer. Okay, so for this is a cosine. Let's do the similar one. Example for sine. Sine theta is 1/2. Okay, sine theta is 1/2. The first solution is to recall the evaluation table. Pi over 6 and 5 pi over 6 sine theta. You see, pi over 6, 5 pi over 6, sine theta is 1/2. So the solution set is theta equal to pi over 6 plus 2k pi, or theta is 5 pi over 6 plus 2k pi for all integer k. Okay, it's the first method. You recall the evaluation table. Second method, you possibly just know sine pi over 6 is a solution. Then what's the other one? Sine pi minus pi over 6 is also 1/2. Here we use a property that sine x is always equal to sine pi minus x. This place you cannot use the even odd property because sine is an odd function. The sine negative pi over 6 is not equal to 1/2, so you cannot use it. But you can use this. Sine x is always equal to sine pi minus x. So you have pi over 6, you use pi minus pi over 6, you get the other one. Pi minus pi over 6 is 5 pi over 6. So the solution set is theta equal to pi over 6 plus 2k pi, or theta equal to, here is 5 pi over 6 plus 2k pi for all integer k. So you get the same quantity, but the second angle you do not get it from memory. You get it from the property. Okay, so this is the property, a very important property. Cosine, you possibly use the even property. Cosine of negative x is cosine of x. For the sine, you use this identity. Okay, and they are both very, very useful identities. They are not just limited for this usage. I just want to recall the important identities. Right? Okay. These two examples, we just give an equation. We don't give any restriction about the angles. And sometimes, when you have this equation, you also have some condition about the angle. The angle theta is between 0 and 2 pi. So it means we don't need 2k pi, but we need a proper selection of k so that the angle is really, the solution is really between 0 and 2 pi. Okay, so to solve this one, first let's check 2 sine theta plus root 3 over 0. So 2 sine theta is negative root 3. Sine theta is negative square root of 3 over 2. Okay, so we first simplify this equation to the simple equation involving trigonometric functions. And if you can get the complete memory for the evaluation table, it's fine. If you don't, when you get this negative sign, remember that you first get the positive angle and then put a negative sign to get negative angle. So that's what I'm saying is the following. First, the solution for sine theta equal to root 3 over 2 has a solution. What's this? Pi over 3. Theta equal to pi over 3. Okay? Theta is pi over 3. This is one solution, but sine is negative. So sine negative pi over 3 is equal to negative square 3 over 2. So negative pi over 3 is one solution. Is a solution. Negative pi over 3 is a solution. Then remember that pi minus negative pi over 3, which is 4 pi over 3, is another solution. Is another solution. Okay? So whenever you have one solution, you use pi minus it, you will get another solution for sine. And this angle is already between 0 and 2 pi, so you don't have to handle it. But negative pi over 3 is not in it. Negative pi over 3 is not in it. Negative pi over 3 plus 2 pi. You can add or subtract any multiple of 2 pi to adjust this, to modify this angle so that it is between 0 and 2 pi. It is in the required domain. If you, with addition multiplication, whatever multiples, you cannot make it in the range, then it does not provide a solution. So here, if we add 2 pi to negative pi over 3, we get, what's this? 5 pi over 3. Okay, so this is between 0 and 2 pi. This is between 0 and 2 pi. So the solution set is 4 pi over 3, 5 pi over 3. Okay, so that's the answer. Of course, if you have the solution evaluation table, then you don't go through this. Just memorize it and write down the answer. Okay, so it's not the difficult problem. And be careful, you have to make your solution in the required domain. If you don't have a complete evaluation table, this is like a detour for us to get the answer. We do not directly get the answer. We get the answer for the positive angle with the property to get the negative angle. And when you have one negative angle, you use pi minus it to get the second angle. And this one, we add or subtract any multiple of 2 pi to make it in the range, in the domain, so that we have two solutions. This is a detour, okay? Okay. Solve. The equation sine 2 theta is equal to 1/2. Theta is between 0 and 2 pi. You see, in the previous examples, we always use the sine theta only, no coefficient. Here you have sine 2 theta. Sine 2 theta, let's just simplify it. We just use u equal to 2 theta. Theta is between 0 and 2 pi. U is between 0 and 4 pi. You multiply 3 sides by 2, you will get u. So u is between 0 and 4 pi. Then we have sine u equal to 1/2. Okay, sine u is 1/2 from the evaluation table. U can be pi over 6, 5 pi over 6, two solutions. And this is from 0 to 4 pi, 2 cycles. So you continue this. You plus 2 pi for each of them. You see here plus 2 pi is a 13 pi over 6. Here plus 2 pi is a 17 pi over 6. How do I get 13, 17? 2 pi is 12 pi over 6. So technically, I just add 12 for each numerator. So 1 pi plus 12 pi, 13 pi. 5 pi plus 12 pi, 17 pi. So this is all the solutions in the requirement, 0, 4 pi. Okay? And, well, u is 2 theta. So 2 theta is equal to those 4 values. Then theta, you divide by 2. Theta is pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. This is the solution set. Okay, this is the complete solution set, and they are all in the range, in the domain 0 to pi. Okay. Okay, let's see another example. Solve the equation. Tangent theta minus pi over 2 is equal to 1. Here, theta is between 0 and 2 pi. Okay, so we do the similar thing. We simplify this formula. Let u be theta minus pi over 2. U is theta minus pi over 2. Then theta between 0 to pi. We subtract pi over 2 from three sides. We get negative pi over 2. 0 minus pi over 2 is negative pi over 2. U less than 2 pi minus pi over 2 is 3 pi over 2. Okay, so this is the range of u. U can only be here. Then tangent of u is equal to 1. Tangent u is equal to 1. Then u is pi over 4. U is pi over 4 in the first quadrant. And remember, u is tangent is a periodic function with a period pi. So you get plus pi, you got 5 pi over 4. Okay, 5 pi over 4 is less than 3 pi over 2. Okay, that's in it. But if you subtract if you subtract the pi, so you see pi over 4 minus pi, you will get a negative 3 pi over 4. It's less than negative pi over 2. So this is not a solution. So you can only add pi. It is still in this range, but you subtract pi, it's not in the range. Okay? So there are only two solutions in this domain. And then theta minus pi over 2 is equal to u. So theta minus pi over 2 is pi over 4 or 5 pi over 4. So theta is pi over 4 plus pi over 2, which is 3 pi over 4, or theta is 5 pi over 4 plus pi over 2, which is 7 pi over 4. These two are solutions. Right? Okay, so here you just clear, you add or subtract certain multiples of a period, and the result is in the range, in the domain or not. If it is in the domain, you choose it. If it's not in the domain, you dismiss it. If you subtract pi, it's not in the domain, then you just don't consider that one. Okay. Okay, so this is another example. Okay, now we want to join the trigonometric functions with quadratic forms, quadratic informal equations, and other more complex examples. The equations quadratic in forms. Okay, so solve the equation 2 sine theta square minus 3 sine theta plus 1 is equal to 0. Theta is between 0 and 2 pi. Okay, so we have a quadratic equation quadratic in form. First, we use u substitution to simplify it. Let u be sine theta. Then we have 2u squared minus 3u plus 1 equal to 0. And this one we can fact it as 2u minus 1 and u minus 1 equal to 0. Okay, remember that. This cross multiplication will give you negative 3. So 2u minus 1 is equal to 0. You get u is 1/2, or u minus 1 is equal to 0. U is 1. So for u equal to 1/2, in the first quadrant, we know that theta is either pi over 6 or 5 pi over 6. Just recall your evaluation table. For sine theta equal to u equal to 1, then theta is pi over 2. There's only one solution for sine theta equal to 1, because you see pi over 2, pi minus pi over 2 is still pi over 2. So there's only one solution. And all these solutions are in the domain 0 to pi. If you add multiples of 2 pi, they will be outside of this range. So we don't do that process. So the solution set is pi over 6, 5 pi over 6, and pi over 2. And that's it. Okay, that is it. Let me see if I have other examples or not. Yeah, let's see this one. For example, let's choose 2 cosine theta squared minus 7 cosine theta minus 4 is equal to 0. A similar problem. And let u be cosine theta, we get 2u squared minus u minus 4 is equal to 0. 2, 1, negative 4, 1. Okay, so what we have? So we get 2u plus 1 and u minus 4 is equal to 0. And 2u plus 1 is 0, u is negative 1/2. U minus 4 is 0, u is equal to 4. So these two solutions are from two separate factors. Okay, so for cosine theta equal to u equal to negative 1/2, you recall the table, then theta is, what's this? It's a 2 pi over 3 or 4 pi over 3. Let's see the evaluation table. Negative 1/2. 1/2 are here, 2 pi over 3 and 4 pi over 3. Okay, that's good. And that's it. Let's complete this. The theta is between 0 and 2 pi. So we have this. And cosine theta equal to u equal to 4. We know cosine theta has a range between 0 and negative 1 and positive 1. The cosine theta has a range between negative 1 and positive 1. So this equal to 4 has no solution. Okay, so only two solutions. This is the solution set. So whenever you have a substitution, you get the answer. And when you try to find the original answers, you must check if you have the solution or not, right? Sometimes those middle step solution will give you the original solution. Sometimes this middle step answer does not give you the solution. It's like if you have a square root, you have to be careful. The square root cannot be negative, right? So it's a similar situation. Okay. And sometimes those equations quadratic in form are not given directly like this one. For example, solve the equation 3 cosine theta plus 3 is equal to 2 sine theta squared. And here theta is between 0 and 2 pi. Okay, you have a cosine, you have a sine. It's not like here this you have sine, then you can use substitution. But this place you have a cosine and has sine. They are not consistent. So you have to make them equal, the same thing. We know that sine square plus cosine square is equal to 1. So sine theta square plus cosine theta square is equal to 1. Here, cosine theta is hard to be transformed to the sine, but the sine square can be easily transformed to cosine square. So sine theta square is 1 minus cosine theta square. So you're going to do the substitution in the right hand side. So 3 cosine theta plus 3 is equal to 2 times 1 minus 1 minus cosine theta square. You distribute this and move everything to the right side, left side. You get a 2 cosine theta square. This is 2 minus negative, and move to the left is positive. 2 cosine theta square. And 2 times 1 is 2. When I move it to the left side, 3 minus 2 is 1. Okay, anyway, you will get 2 cosine theta square plus 3 cosine theta plus 1 is equal to 0. Let me write one more step. Here is a 2 minus 2 cosine theta square, right? When I move these two terms to the left side, you will get this. And we can factor it as 2 cosine theta plus 1 and cosine theta plus 1. You can use substitution. You let u be cosine theta and continue. If you are familiar with this process, you don't write u. U is just middle word, middle step. It does not play important role. Okay, it's just simplify the writing, but does not play important. Okay, so 2 cosine theta is equal to 1. So cosine theta is equal to negative 1/2. Or cosine theta is equal to negative 1. Cosine theta is negative 1/2 theta. Sorry. Then, okay, cosine theta is equal to negative 1/2. Theta is what? 5 pi over 6 or 7 pi over 6. And cosine theta is equal to 1. Negative 1, then theta is equal to pi. Okay. No, pi percent. No. This is cosine. Yeah, so that's why I feel confused. Sorry, my memory was wrong. Okay, this is 2 pi over 3 and 4 pi over 3. Okay, now it's right. 2 pi over 3 and 4 pi over 3. Cosine theta is negative 1/2, then theta is 2 pi over 3 and 4 pi over 3. Yeah, the evaluation table, you must memorize it correctly. This is wrong. My bad. Cosine theta is negative 1, then theta is a pi. This one is correct. Yes. So the solution set is 2 pi over 3, 4 pi over 3, and the pi. That's it. Second time. Let's see a second example about this type. For example, we solve the equation. Cosine theta square plus sine theta is equal to 2, and theta is between 0 and 2 pi. Okay, solution. Cosine, we know that again sine theta square plus cosine theta square is equal to 1. So cosine theta square is 1 minus sine theta square. This trig identity is compatible with the square form. It is not compatible with the sine and the cosine directly, with the sine square cosine square directly. Okay, so cosine theta square is 1 minus sine theta square. So the equation becomes 1 minus sine theta square plus sine theta is equal to 2. We simplify it. You see it's a negative sine theta square plus sine theta. We move 2 to the left side, it's minus 2. 1 minus 2 is negative 1. And we multiply this equation by negative 1. I want a positive leading coefficient. Positive leading. Well, here's the thing. Let's try to determine. This is a quadratic in form. You can check it. You cannot affect it. If you cannot affect it, you're going to use root formula. For the root formula, you check the discriminant. B squared minus 4ac. B, negative 1. Negative 1 squared minus 4. A is 1. C is 1. Negative 3. No real solutions. No real solutions. So the equation has no real solution. Okay, that's it. If the quadratic type function has no real solution, composed with a sign, it does not have real solution either. So the solution set is the empty set. We have a symbol. Empty set means this. You put a circle and cross it. Okay, so this is a trigonometric equations. In the trigonometric equations, you just use original technology and simplify it to some evaluation, like sine theta is equal to something, or cosine theta is equal to something, or even tangent theta is equal to something. And when you have that simple form, you have to use your evaluation table. And the evaluation table, remember that here, this evaluation table, we actually only memorize this top left corner, and the other part we have some pattern. This go up and this go down, and copy it, put a negative sign. For the second row, you shift it. You shift from this point to this part, and the first one to the last one. So this is the evaluation table. So that's why we only memorize this top left corner. Everything will be solved. Okay, so this is the section 8.3. 8.3 is not easy, but it's not difficult. So you have to, it's a comprehensive. You have to use whatever knowledge you have and try to solve it. Okay? Okay, very good. Do the exercise, very, very important. And do the recommended exercise. If you have questions, send me email. We will stop this video and start a new video. Thank you.